Properties of logarithms. Okay, so a logarithm is kind of like the inverse of an exponential equation. And we utilize logarithms to solve exponential equations and functions. So we have logarithmic functions and exponential functions. Now I've written both of them here for you. This logarithmic function, we've talked about this first one. It's b to the y power is equal to x. We've talked about it in the form of like graphing it and growth and decay, where the exponent is a variable. This form can be converted to this form down here, where it's log base b of x is equal to y. Now here's the thing. This is red log base b of x. Now, here's the thing. There are different bases in our number system, and a lot of these bases are used with computer programming, different types of bases. Like we have base 2, which some of you interested in computer programming would know that that's where you have 0, 1, 0, 1, 0, 0, 0, 1, 1, 1. If you've ever seen that on a computer, whenever maybe a code is tripped or whatever, that is because it's red in base 2, which is a different number system. And the reason we have these different number systems is because it makes it easier for the computers to read them and to follow commands and prompts. Now, here's the thing. If the base is not written, it is understood to be 10. 10 is our number system. It's our counting system. 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are our digits of numbers. And then they repeat with 1 and 0, and then 1 and 1, and 1 and 2, and all the things, and those numbers are used in our number system. So if the base is not written in a logarithm, it's understood to be in our system 10. So that's why you'll have differentiation of bases. Sometimes it will be written, sometimes it won't be written. If it is written, that means the base is changed. If it is not written, then it's understood to be 10. Now, these two equations are in, like, they can go back and forth. So you can go, and this is kind of how I like to kind of go over this, you can go from one form to the other. B to the power of y is equal to x. We take the base that's over here and we make it the base over here. And we just write it as a logarithm. So what does that mean? That means y is equal to log base b of x. That's this formula up here, okay? So whatever you have over here as the base becomes the base on the other side. The same thing for the logarithm. So if I have log base b of x equals y, then I can take the base here and make it the base over here, meaning that I can drop the logarithm, say x is equal to b to the y power. It's kind of like a little flip and switch. You can just take the base and make it the base on the other side, converting it to a logarithmic form or converting it to exponential form. So let's do a couple of examples of just doing that, converting from one form to the other. So for example, let's go to logarithmic form. Let's say I have 100 is equal to 10 to the second power. And we just want to write it in logarithmic form. I don't want to do anything else. So I'm going to take the base that's over here, wherever the exponent is, and I'm going to make it the base over here. So this is going to be log base 10 of 100 is equal to the exponent now, which is 2. You need to just switch it. Log base 10 of 100 is equal to so let's look at another one. Let's say this one is 3 to the power 4 is equal to 81. So 3 to the power 4 is equal to 81. So the base here becomes the base over here. So this is 4 is equal to log base 3 of 81. And that's it. So you're going from one form to the other. If we wanted to go from exponential or from logarithmic form, so from logarithmic form to exponential form, we would say maybe the logarithm is log base 8 of 32 is equal to x. Then we would take the base that is over here, and we would make it the base over here. So we're going to drop the logarithm, have 32 equal to 8 to the x power. being able to go from one form to the other one easily is really important. And it's really important for how to kind of simplify logarithms. So yeah, let's talk about how to simplify a couple of logarithms and different types of logarithms. To simplify these, it's actually really easy to do the 32, this one, 32, 8 to the x power. If we write it as an exponent, we keep it in exponential form. I just want to talk to you about how to simplify in exponential form, because it's keeping it in exponential form can be simplified. Now the thing is you want the bases to be the same. If my bases are the same, then I can drop my base and set my exponents equal to one another. So what bases could I make these to be the same? Well, we have to think exponential, okay? So anything to a power that equals 32. Well, 2 to the power of 5 is equal to 32. Just like 2 to the power of 3 is equal to 8. But don't forget that we have that exponent that's x, okay? So we're rewriting so that we get the same bases. And this is a really cool way to simplify these because in order to solve it, you can solve for x and find the solution of x. So simplify, in these cases, we're solving, okay? We're solving for x. But in order to do this, we need to have the bases be the same. Remember, to exponent, the exponent's power to a power we multiply. So 2 to the 5th is equal to 2 to the 3x power. So now I can drop the base and set 5 equal to 3x. So the bases go away, and we just set the exponents equal to one another. Solve for x, 5 over 3 is equal to x. So that's a really easy way to solve for your exponential functions. But sometimes it doesn't work out that way, and we do need to utilize logarithms, but we'll talk about that when we get to it. Let's look at one more. If I have log base 5 of 125 is equal to x, then I need to solve this one. So I'm going to take the base here and make it the base over here. Changing it to exponential may help us solve it and simplify. So this is going to be 125, drop the logarithm, 5 to the x power. Now I'm going to rewrite my bases, and this is 5 to the third power is equal to 5 to the x power. Drop your bases because that I have 3 is equal to x. Okay. And a couple of things that we want to kind of talk about, and there's some properties that we want to go over. Just a couple. 2 properties that we're going to go over more next class is one is to simplify a logarithm, log base b of b is equal to 1. This is the first property that I kind of want to go over with you. There's a few other properties, but this is the main one, and it's log base b of b is equal to 1. So if you have the base of what you're taking the logarithm of, it actually equals 1. So this actually could have been solved a different way. I could have said that this is log base 5 and rewritten 125 as 5 to the power of 3. Now if we're going to do it this way, we actually need one more property, and that is our second property, which is called our power property. Now your power property states that if I have log base b of a number raised to another number, so I have a power to or a function to a power, this is going to be the power written out front. We can take that power, that n, and write it out front of my logarithm, and then I have log base b of m. So up here, because I have a power in the logarithm, I can write it out front, being 3 log base 5 of 5. Log base 5 of 5 is 1 because it's log base b of b. So this becomes 3 times 1, which equals x, which is just 3 equals x. So there's multiple ways to look at this problem. This is using logarithms. Can't spell. Logarithms in order to solve and simplify. A couple of things, and we'll talk more about these next video, but it's log base b of 1 is equal to 0, and then log base b of 0 and log base b of a negative number do not exist. So these two do not exist. That's DNE for does not exist, okay? So these are some properties that we're going to go over more next class, but just kind of keep in mind it's a way to simplify these, so you may run into some issues or you may be able to just do them like you can with exponential. So making sure the exponential that you're getting the same bases so you can drop the base and simplify and solve the problem. That is it for this video. We will pick up with properties of logarithms. Our properties of logarithms are day 2. Okay.